Okay, so we'll be proving the reduction formula of the integral of cos to the power of nx dx. So as you can see, first we can break up cos to the power of nx to cos to the power of n minus 1 x multiplied by cos x. So we'll be choosing our u to be cos to the power of n minus 1x, while our dv to be cos x dx. So next we'll need to find our du and our v. So let's write down u will be cos to the power of n minus 1x. Therefore du will differentiate u by bringing down n minus 1 cos, put brackets around this, then subtracting 1 from the power, so n minus 2 x. Then we'll be doing the chain rule, which is negative sine x. So for dv we have cos x dx. Therefore v will be integral of cos x, which will be sine x. So now we have all the 4 components that we need. We can get started on this formula. So write down the left hand side, which is cos to the power of nx dx equals to u multiplied by v, v being sine x and u being cos to the power of n minus 1x. So we subtract the integral of v du. The du is actually quite a complicated expression. So we have n minus 1 here, which is constant, so we can take it out from the integral and put it out in front. So we get us this n minus 1 cos to the power of n minus 2x sine x, and v being sine x. Oh wait, sorry, made a mistake. This should be negative sine x, negative sine x, and then we have v to be sine x, and finally d x. Remember this. So now we can write down the left hand side again and write this part down again, and as you can see we have a negative sign here and negative sign out in front, so negative negative and we get a positive. So positive n minus 1 integral of cos to the power of n minus 2x sine x multiplied by sine x, there will be sine square x dx. So we just leave it down. I'll not be writing it again. And yeah, these two parts you can just bring down, and you can just do this side first. Right, so we have sine square x here. Everyone still remember the trigo formula? Sine square x plus cos square x equals 1. So sine square x equals 1 minus cos square x. So you can use this and sub it in here. Okay, let me just rewrite the whole thing again. Let's move it down. Okay, I'll just write the whole thing again. Cos to the power of nx dx sine x cos to the power of n minus x plus n minus 1 integral cos n minus 2x 1 minus cos square x dx. More space here. So for this side, we have cos to the power of n minus 2x multiplied by 1. So we just get back itself. And cos to the power of n minus 2x multiplied by cos square x. You get cos to the power of nx. The 2 here cancels out. Dx. Oops. We remember that we're integrating this whole thing together. Okay. So after this, can split this apart by doing this. Cos x minus n minus 1 cos and x. Oh yeah, and do not forget the dx at the back here. So, yep. Okay, so we've gotten somewhere. So notice there's a cos to the power of nx here, and also cos to the power of nx on the left hand side. So we can bring this over to the left hand side, and they'll cancel each other out. So we will have cos to the power of nx dx plus, because here's a minus, bring it over, it'll be plus n minus 1. Okay, and then cos to the power of nx dx. And what we can do for this part is expand it out. So n cos of nx minus, the integral of it dx minus integral of cos to the power of nx dx. And as you can see, these two cancels out because of the subtraction. So we have the left hand side, which will get us, so all we have left on the left hand side is this n cos to the power of nx dx, which equals to the right hand side, which is this. Tricky. Hold on a minute. Yes, which is this whole expression right here. So it would be sine x cos to the power of n minus 1x plus n minus 1 integral of cos to the power of n minus 2x dx. There you go. Nice. So remember what we initially wanted to prove was this thing right here. So if you can see that we have actually got it or we are almost there. But instead of integral of cos to the power of n x dx on the left hand side, we have an n here. So we'll be dividing everything by n. And we'll get cos to the power of n x dx equals to sine to the power of sine x, sorry about this. It will be sine x multiplied by cos to the power of n minus 1x, and because divide everything by n, we have a n minus 1 here. You can see. So, 1 over n, basically. So, do this, and n minus 1 will be over n, and cos of n minus 2x dx. Okay, so there you have it. The reduction formula for the integral of cos to the power of nx dx proven. So next we'll be applying these formulas to some other equations to make our lives simpler. Cool.